Dear students, today we discuss about the FM demodulator. We know what is demodulator circuit, the electrical and electronic circuit which used to separate the message carrying low frequency signal from modulated wave. The FM demodulator, FM is the frequency modulated wave which consists of carrier wave frequency and a wave with a frequency above the carrier wave and a wave with the frequency below the carrier wave. We have to separate the low frequency signal, that is message carrying signal, from the frequency modulated wave. For this purpose, this circuit is used. The circuit is consist of the transformer, a tuned capacitor, and another carrier capacitor tuned for the carrier frequency, and the two diodes A and B connected opposite in polarity, and the two capacitors C1 and C2, and another capacitor C3, and finally a resistor R1. So another resistor R2 is connected to secondary, the center of the secondary of the transformer to the center of the capacitor C1 and C2. So this circuit is used to extract the low frequency message carrying modulating signal from frequency modulated wave. In this connection, the question is explain how a frequency modulated wave is demodulated, or explain FM ratio detector. This circuit is also called as ratio detector. The circuit used for the demodulation of frequency modulated wave shown in figure. Here the diode A and B is connected in reversed polarity. So both the diode conducts at the same radio frequency of cycle. When the FM frequency modulated wave is received from the antenna, it is passed to this primary of this transformer circuit, and then it is induced to the secondary of the transformer circuit. Whenever the bottom of it has two portions, upper portion and bottom portion. Whenever the bottom of the transformer secondary is positive, it causes a rectified current to flow through the circuit. So as it is in the forward bias, so the current is passed through this, and then finally it reaches the resistor R1. When the diode A and the secondary coil, therefore a direct voltage developed across the resistor R1, which charges up the capacitor C3. This capacitor holds the voltage across the resistor. This voltage is from the diode. It is rectified voltage. It is developed across R1. This is charged by the capacitor C3. So during the non-conducting cycle also it holds the voltage. When the frequency modulation is present, it is relative to the two rectified currents through the two diodes. So during the negative cycle, this diode conducts. During the positive off cycle, this diode conducts. So both the diodes are conducts at all time. So the voltage is available for all the frequency. So the voltage is developed across C1 and C2 to vary correspondingly. So the voltage across the C1 and voltage across the C2 varies correspondingly. One increase, if the voltage in the C1 increases, the voltage in the C2 decreases. If the voltage in the C2 increases, the voltage in the C1 decreases. So one increasing as the other decreases, but the sum of the voltage across C1 and C2 remains constant, since the voltage across the capacitor C3 remains constant here, and it is independent of any variations in the amplitude of frequency modulator signal, which may occur due to the noise and other disturbances. So, the voltage across C3 always constant due to the sum of the voltage created across C1 and C2. So, the ratio between the individual diodes output voltage varies continuously with instantaneous frequency of frequency modulator signal. So here both the diodes are in the reversed bias. So the output voltage of the first diode and the output voltage of the second diode B varies continuously. The variation depends upon the variation in the frequency of frequency modulator signal that we fed in the input circuit. So, depending upon this variation, due to the variation in the frequency modulator signal, it produces the amplitude, that is the low frequency message carrying signal in its output. So due to this, the ratio between two diodes, the voltage varies. So hence it's the name ratio detector. The audio frequency output, that is the low frequency message carrying signal, that is called as AF. Its output voltage is taken across any one of the capacitor or across R. So the original message carrying signal is recovered from this circuit. The frequency modulated wave is given to the circuit input. The output gives the extracted message carrying low frequency signal. It is the simple action of this ratio detector or frequency demodulator.